everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a Wormable NFT marketplace bug, an SSRF and VMware Workspace 1 UEM, a container escape and GitLab CI Runners, and more. And before we get into topics, thank you, by the way, to Imperial Give for the 8 months. Appreciate it. So, yeah, just wanted to call that out really quick. All right, so first we have a topic that we were going to cover a few weeks ago as a different blog post, but unfortunately at the time we felt there were some details missing and it was a bit fuzzy on what the issues were, so we didn't want to cover it at the time. Recently, though, we found that there was a different post that talked about it from Palisade, so we thought we'd cover it today and kind of bring up both posts. So this is a vulnerability in Rarible.com, which is an NFT marketplace where you can post and sell and buy NFTs and such. And last month, Palisade Consulting reported an XSS and a web application firewall bypass that could execute JS on a victim's machine. And in this case, that's a little bit more impactful than it would be usually because, with Web3 and you're dealing with the web extension-based wallets, you can do some really interesting phishing attacks and such with that kind of position. So the XSS itself was the fact that the photo parameter in the user profiles wasn't sanitized. They don't go into too much detail there. My guess is that they're just pulling in like a user link for an image or whatever for a photo and then putting that in straight in. So yeah, they don't sanitize the photo parameter. So anyone who could have your malicious picture rendered, which would contain a JavaScript payload, would have that malicious code run, and then that itself could set their own profile picture as a malicious payload, and that's where the worm propagation aspect of it comes from. To get around the Cloudflare firewall, they just simply encoded their payload in base64 and decoded it when evaluating. I'm like
not sure what exactly
high, though.
The bypass here is. I mean, Cloudflare bypasses tend to just be combine a bunch of tricks. So, I mean, yeah. So they did the base64. I don't think that's going to be sufficient to just bypass the WAF just using base64. Otherwise, everybody would be doing that. And Cloudflare bypasses are usually at least somewhat novel. There does seem to be a few things going on here. Obviously, A to B for the base64. A little bit of trickery when it comes to the Unicode values. There's a few things here that can be messing up with the parsing. I don't really want to speculate on exactly what Cloudflare is doing to make it work. They just propose it as this worked for them. And no information on whether or not Cloudflare's updated their WAF to prevent that.
Yeah, they specifically call out the base64 in their post, though, so that's why I wanted to just bring that up quickly while we were talking about it. So yeah, I mean, from there, they basically pocked trying to write a payload that would modify the price of a Bored Ape, and then get the user to try to sign that transaction. Just demonstrating some of the kind of phishing attacks that you can pull off there. But yeah, I think the main reason we want to talk about it is because of that aspect of it, where it's a little bit different than like your typical XSS.
Yeah, so I thought this aspect was kind of interesting. In part because the way a lot of the Web3 things work is you're going to have an extension installed, and then when you want to sign a transaction to actually send out and like do a transaction on the blockchain or whatever, you're going to operate through this extension. And the thing with that is that extension, unlike a web application where you would maybe have cookies or something kind of showing you're signed in, like everything can, in theory, every website can start communicating with that. Just, import Web3 or whatever. A little bit more complicated than that, but there's effectively the Web3 JS you can add on as a script and then like do all of that work. So when you have an XSS on, something where people likely have that installed, that becomes a new attack surface where it doesn't really matter if your XSS is even running in the the Rarible domain or whatever, because you can just start accessing that and get that Web3 prompt to show up to be like, hey, go and sign this transaction, whether or not it really makes sense for the page. So sure, I mean, if you did that on like the checkpoint vulnerability, I believe it was in SVG, and you would get it when it displayed on the profile, but you would also get it when if you just visited the SVG itself. And if you just visited the SVG, that's going to be a bit of a weird page to get that prompt on, but it would still cause that Web3 prompt to happen. It would still go through all of that, which just makes it kind of an interesting attack surface if you're in an environment where that's likely to be using that as kind of a basically a way of escalating an XSS that isn't in like the normal domain. It's something else you can go and hit. Obviously, it's going to be a little bit context dependent, but I thought it was an interesting idea. The way they went about it here for their little phishing attack was, as Spectre said, they modified the price to make it look cheaper to kind of encourage them to actually sign this malicious transaction. They think they're going to buy it for cheap, but they're actually signing a transaction that approves the attacker to take all of their NFTs. And they're able to query a bunch of that game because of the Web3 aspect. I thought that was just an interesting thing to bring up here. They did get a $5,000 bounty here out of Rarible for finding this. On a whole, the vulnerability seems straightforward. Like Spectre said, we just see what this final payload was. So presumably it's taking like a URL or something. As I mentioned, the case of the checkpoint. So initially, I actually thought this was talking about the same vulnerability because it was another sort of XSS. They were dealing with Bored Ape also, and they had like a similar attack mechanism. So I actually thought these were the same vulnerabilities when I looked at it, and they're not the same vulnerability exactly, but they do a lot of the same things.
Yeah, so like this Palisade one where it's with the profile pictures, the checkpoint one was with the art itself. For like I think the posting page for like the NFT, and they would allow SVGs. So yeah, it was a little bit confusing for me too. I was kind of in the same boat. But
Yeah, I
they
was
are
just
slightly different attacks,
biased
it seems.
because I had read that, and they came out just days apart. This one was April 18th, the other one the 14th. It's the end. Chav mentions it seems kind of low. I assume you're talking about the bounty, and yeah, $5,000 on like a crypto relay bounty does seem really low. That said, because it is a XSS on like the crypto site, I feel like they're probably just getting away with doing normal web app kind of bounty pricing, in which case $5,000 for XSS isn't that crazy. Like, it's not high, but it's not that off either.
Yeah, I mean it's a little interesting because usually when we're talking about crypto bugs, they're in smart contracts.
Yeah.
And that kind of comes with their own like challenges when it comes to deploying fixes and the amount of damage that can be caused. This one, it is more of like a phishing type issue, or for like attacking users in that sense. So the
I mean,
impact
the
is a bit lower
XSS
than
is
some of the
real.
typical crypto bugs, but yeah, I'd kind of agree. 5,000 does seem a little low, just because of the context surrounding it.
I mean, the XSS is low. They can't make transactions as a user because it does all happen on the blockchain. So that actually is almost a mitigating factor in the fact that the XSS actually does require user interaction to do anything because of that. But they can also worm it and all of that. The worming aspect's kind of fun. It's been a while since, or I don't think we've even covered any wormable XSS on the podcast before. I
I
don't
don't
know.
think we have either.
I always come back to thinking about Sammy Kamkar's what was that? MySpace? I'm already forgetting the name, but yeah, MySpace XSS worm way back when.
Yep. All right, so we'll get into our next topic here, which is an SSRF in Workspace 1 UEM, which is like an enterprise solution for corporate data management and provisioning mobile apps and such for corporations. This was put out by Asset Note. The vulnerability and attack scenario here is not really new. It's something we've seen before on the show, as it basically boils down to the fact that this user provided encrypted URL parameter would get used and proxied to in some applications bundled with Workspace ONE UEM. Here they focus on AirWatch, I believe, and they just assume that encryption protects from like untrusted input or arbitrary attacker input. And there's kind of two problems here with their assumptions here. The first of which is you don't you need to use some form of signing to guarantee authenticity of data. Just encrypting it on its own isn't really any guarantee on its origins. You have to use, signing or something like that uh, to verify authenticity. The other problem is, depending on the user provided key version, if it's set to KV0 or if it's just not set at all, it falls back and defaults on using hard-coded encryption keys, which obviously can be pulled by an attacker and opens up the URL parameter to attacker control, because now they can encrypt their own data, and it'll get decrypted properly and as expected. So kind of those two issues put together allow for the SSRF to take place. The rest of the post mainly talks about writing their own tool to do the encryption in the POC. But mainly, I mean, the main takeaway from this post is just another reminder that crypto does not equal authenticity on its own.
Yeah, you need more for integrity. I mean, so crypto, there is authenticated crypto. So that does
Yeah,
exist
you have
that you
like
can
HBAC or
use.
something.
Well, so there are crypto systems that have some of the authenticity checks or integrity checks built into them, like AED for AES and AED mode. Will do that. So like that exists without needing to add the extra layer on. So it does exist, but this generally isn't the case. If you use something, I want to say, like most crypto libraries, if they provide like a secret box, will probably be doing that automatically for you. In this case, obviously they're not, which is kind of the other giveaway or thing to take note of, is the fact they kind of just have this data encryption class that they make with the encrypt string or decrypt. And just having those sorts of things, it's like rolling your own crypto, as I've said a number of times, isn't just like writing the AES routine yourself. It's rolling your own protocols that involve crypto. Ideally, you should avoid doing that too, because it's hard to get everything right unless you have a lot of experience dealing with crypto and all the ways it can go wrong. So yeah, this is just another one of those cases, hard-coded key in there. Users are able to kind of force use of that key and then encrypt it for themselves. Ultimately, I mean, it is a little bit more complex than just encrypting the URL, and you would have to do a little bit of work to figure out exactly what everything means. They kind of had to walk through the code a little bit here, but it does boil down to a pretty simple issue.
Yeah, it's worth calling out that they also did discover some variants, because this code, I think it's like this blob handler, was deployed in multiple applications. So yeah, towards the bottom of the post, they say, like, I called out the fact that it was in AirWatch, but they also call out it's in Wandering Wi-Fi, Catalog, and the AW console. So yeah,
Well, so I
so
think Wandering Wi-Fi is where AirWatch blob handler.ash
yeah, sorry,
is.
yeah,
So
you're
it's a
right.
two applications, not four. I
Yeah,
think.
sorry, you're right. They just kind of explain a bit more of the endpoint
Uh,
tagged on there. Yeah, fair
well,
enough.
the file name versus class path.
Yeah. Um, but yeah, just one of those things where it's like crypto on its own. You have to use it properly for it to be effective, and it's really hard to use it properly. Properly, evidently,
Yeah,
as we end up proving time and time again on the show.
yeah. I mean, it's one of those areas like when I do code review, I would just grep for AES for crypto for uses of those terms because odds are they're just going to use it wrong somehow. Sometimes it's exploitable, sometimes it's not. Sometimes it would just be some informational thing. But probably like 90-95% of the time when I saw crypto being used, something was wrong and there was some viable attack going on. So, I mean, it's hard to get right. Um, and I'll just shout out, since we're kind of talking about it, the book Serious Cryptography. If you kind of want to get a introduction on the crypto side of things with more of a security focus, I really like that book.
All right, so for our next topic, we have what Z thinks is the most straightforward 2FA bypass he's ever seen. This is in an undisclosed website detailed by Sufyan Guri. Sorry if I pronounced that wrong. While we don't know the target, the details on the setup are good enough to be able to understand the issue. Basically, the site had the standard password reset mechanism where you request a password reset, a link gets sent to you with the token, and you can enter a new password, and then it'll redirect you to the dashboard using the reset endpoint redirect. Now, when you have 2FA enabled, instead of redirecting you to reset, it would redirect you to this reset 2FA endpoint to prompt for two-factor authentication. Funny thing is, it seems you could just capture that request and modify it to send yourself to the regular endpoint instead of the reset 2FA endpoint. And yeah, you could do that and bypass 2FA. So
Yeah, I
yeah, I
mean,
think it might be one of the easiest 2FAs we've seen.
yeah, this is one of those, just for a little bit of clarity for the listeners, it's one of those setups where you kind of have the two stages to it. You enter the username and then you kind of go through. It does seem like they're also entering a new password before they do the whole 2FA stuff, so I think we had that discussion a little bit about how that also feels like a little bit of the wrong order, but I mean, the fact that they just have this post going on, just change it to reset instead of reset to FA, like the two different endpoints, and they don't check the account should be using that endpoint, is kind of like, is definitely something that should catch your eye. When you see the same sort of functionality being duplicated because of this 2FA, you know, there's maybe the case of being able to bypass it, as they do here. But yeah, definitely fairly straightforward. Literally just delete 3 characters.
Yeah, so not a super long post or, super interesting post for the attack that's happening, but
No,
kind
but
of a
it's a
funny
fun
one.
attack.
Yeah.
Good find.
So getting into some HackerOne stuff, we have kind of a 0-day report in GitLab CI Runners. I say kind of a 0-day because this bug was closed as informative by GitLab staff, and they've known about it for a while, and they don't really agree with it being a security issue, which I think we'll get into in a little bit. But what the vulnerability reported here is the fact that the CI containers in GitLab are overprivileged and can mount file systems inside of the container, and thus they have the ability to abuse the cgroup release agent functionality for a container escape. This report doesn't go into a lot of detail on that, but it's a documented container escape vector. I believe Trail of Bits did a post on it, and
Yeah,
I think we
Trail
might
of
have covered some
Bits.
reports that use that trick as well, but I'm not 100% certain on
It
that.
did feel vaguely familiar, but yeah, Trail of Bits, I think, did a good post on it. I think it was first documented here by Felix Wilhelm, as just a quick and dirty way of getting out of privilege, K-Pod, who ends up documenting, or basically just providing the Twitter post of an escape with it. Not a ton of explanation there, then Trail of Bits. I took it forward. So yeah, it's a documented thing. It's been known about. Effectively, that release agent's going to get executed when a C group, when something under it. So you mount the C group. When something under it gets cleaned, if notify on release is set, so just like echo 1 to notify on release, it'll execute whatever the release agent binary or path is. So you can set that to your own script. That's going to execute on the host, giving you, as they do here, a reverse shell onto, I guess I say the host onto the VM. So this is a container escape into the VM, which is where GitLab, in other reports they've had reported on this, where is it? I think it goes back 2019. Somebody reported something similar. I think it's in a comment here. They have the
Yeah, it
bug
was
report.
it was a Git issue, and yeah, I think it was like 3 years ago or something like that. Um, so yeah, like the researcher goes into detail on why they think this is a problem, um, noting that CI goes out of its way to prevent access to GCP metadata and host configuration information. GCP being Google Cloud Platform. And this container escape would allow direct access to that data and other hosts on the internal GCP network. This could also be used to disable IP tables and get arbitrary software and images ran, such as like crypto miners or something. There's also the potential for leaking information between jobs if multiple jobs were scheduled on the same dedicated runner. Although that's kind of left as a hypothetical. They didn't run into this situation when testing.
Well, so it does seem like GitLab claims that that won't happen. In the
Okay.
ticket, they end up talking about this, and they basically talk about how a lot of like the information you could leak there, like yeah, you can link those tokens, but you can only basically access logging with it, like write logs with the tokens. That's not very valuable. This is a container escape into a VM, so it's not like onto the full host system. Um, I do also kind of disagree with GitLab here in terms of just deciding they're okay with it. Like, fair as a company, they can decide they're okay with that risk, but part of the point of using containers is like to have at least this extra step needed. So if you don't deal with the known ways of getting out, why even use containers in the first place? I mean, it does add a little bit of extra work. They do need to figure that out, but um ultimately, I mean, it feels like a disaster waiting to happen. As soon as somebody has the VM escape, then they don't really need to worry about the container escape. They just need the one thing. Um I will also mention here that EC0 here, the guy that reported this, also did a talk at NahumCon, which was just this past weekend, about these sort of CI escapes. I haven't watched it, so I'm not sure what all is detailed, but there's probably more information here on his thoughts on this side of thing in his post, since he indicates that he's going to be talking specifically about this vulnerability in that talk. So I'll shout out that that's there, and pretty sure the videos are already, well, at least they're currently available on Twitch, I think. I can't remember if I checked YouTube. Or maybe they're on YouTube. I don't know. They're available. You can Google it, or I'll add a link to the show notes.
Yeah, we'll have them on the website for anyone who's interested in that. But yeah, the other thing is that the author pointed out is they don't see a reason why these containers should be privileged enough to mount file systems this way in the first place. And they think it should be an easy fix to just tone down the privileges on the container. That said, there might be some internal reason that GitLab doesn't do that. I didn't see anything in the GitLab issue that Z was just talking about that touched on that part of it. I would have to think that there would be some reason that they can't fix it so easily, just because we've covered a lot of GitLab issues, and we've never really seen GitLab handle a report badly. It seems like they take security pretty seriously, so I would think there would have to be a reason other than they just don't want to fix it. Um, but yeah, that's kind of the report author's thoughts, is that this they really should just be toning down the privileges on these CIs. I don't really know why like a continuous integration runner would need to mount file systems. That seems like a pretty big privilege to give them that I can't like I haven't done a ton of CI work, but the bit of CI work I've done, I've never thought to myself, I need to mount file systems for this to work. I
Well,
don't know if
so I could
you
imagine
disagree
the
on that, Z,
case
but
of having some sort of like, the using Fuse or something and mounting a user space file system. I can see a sort of thing going on there where they might want to mount something, but specifically, part of it is also the C groups aspect. That comes apart from the privileged. Um, just being able to mount the C groups rather than just mounting like a new old file system. So
yeah.
I'd say that's also part of it. I kind of agree. Like, I don't see a big reason for it, but I do feel like there's probably a reason why they're at least keeping privilege, even though with mounting, like I said, I could see reasons for mounting in general, just not C group access.
Yeah, and Tanewa in chat said CI/CD mounting FS would probably be to create an isolated environment for each one, make it easy to clean. You don't need root to mount with Fuse either. Yeah,
So
I mean
volume
that's
mounting, I think, is also a little bit different here with the containers. Like, you can create an isolated environment in that way that I think would be separate from the actual running the mount command in the container. But yeah, you don't need root to mount with Fuse, so like there are ways that you can go about this, and it's just on the C groups aspect that they gain from this being a privileged box, and we don't have the information on why they chose to keep privileged in there.
yeah. Unfortunately, without knowing more of the internals, it's a bit hard to comment on like uh what steps GitLab could really take here. But overall, GitLab just doesn't really agree with this issue being like a high impact issue, like Z touched on earlier. They say that it's only used for writing to GCP logging and monitoring. They don't use the Google Service Account tokens for caching or anything like that. That original issue, that original issue that they talked about from 2019, like that is 3 years ago. Something could have changed since then, to be fair.
Yeah,
But
that's an
yeah,
important thing to call out. There definitely could be changes from what was accessible 3 years ago to what they're doing right now. But on a whole, I mean, this just feels like defense in depth. Like, you have an issue, you have these layers of security. Take advantage of them if you're going to use secure them.
Yeah, and that's kind of I guess another point in favor of like why it's kind of a bad idea to leave this unfixed is the fact that, you know, code changes and something that might not be exploitable today could be exploitable tomorrow.
Yeah.
Taniwa in chat also called out syscalls like unshare also work in containers too, unless you disable it on the host and you can gain Linux caps with that. I would be very concerned if any like public CI container setup was able to had user namespaces enabled. That would be really insane because that's just way too dangerous to expose that much kernel attack surface.
Yeah, and I
and
guess
there is no reason to do that.
part of the thing is as long as they keep it as a privileged box, like it is going to have all of these privileged, a privileged container. As long as they keep that, like it is going to keep all of that access. Like
well, unshare, you just shouldn't be like configuring the kernel with that for running containers in general. Like in this context.
I mean, don't you kind of need the namespaces for containerization? That kind of part of how containers tend to work is using the namespaces.
I guess it depends on the container technology. I think we've talked about this a little bit before. Like, does Docker use user namespaces? I'm trying to think.
Well, I believe so.
Yeah,
like Docker's built off of all the C group stuff. Like it's built off of all of that tech there. So, you're going to have the namespaces enabled. Like you can't just enable that outright. Actually, in fairness, Docker did do some. This was, I guess, a few years ago, so maybe my knowledge is a bit out of date. But I know they rewrote like their container environment or something. I don't know, so I'd have to look to specifically say yes, absolutely, Docker does. But it does feel like one of those things that it's not as easy to just straight up not allow that across the entire kernel, because that was at least historically with like LWC and stuff, which precursor to Docker, would have used some of that.
Yeah,
either
that's
way,
true. So it is kind of a necessary evil, but yeah, it should be being privileged off in a way that it can't be abused, but it's possible that it's reachable, and yeah, I guess that's a fair point to raise too.
Yeah, I mean, I just come down to it does feel like there's some architectural reason that they're choosing to run this as a privileged container. And I mean, essentially, you know, ignoring the C groups aspect, if it's a privileged container, there are almost always going to be some escapes out there. There are a number of escapes when it comes to privileged container. People are continually even coming up with newer ones. So like that feels like the fundamental issue that kind of either needs to be resolved or maybe clarified as to why all the runners are in that. If it's a privileged container, it's going to be escapable. So, like talking, I guess, about something specifics just feels like the wrong discussion to me.
Feels a little superficial, yeah. Yeah, so like Z said, the problem there is just running these privileged as, or running these containers as privileged as they are. That said, when you're starting to get into these infrastructure type issues, they are also getting into the more difficult to fix territory, because if you rely on those privileges, then you have to find a way to work around them that's secure, and that's not like easy or cheap at all. That takes a lot of developer effort to redesign their containerization to work that way. So yeah, from GitLab's perspective, they just don't think it's worth it, and you know, like you said, at the end of the day, that's their call to make. So
yeah, at the end of the day, like on its own, because this is into a very weakly privileged VM, like it is somewhat fair to decide that it's not a huge priority. Like I can while I disagree with making that choice, I can understand that choice. Like as a company, you have to prioritize things, and sometimes security just, or like the utmost perfect security just isn't there when we're talking about the runners, which are already running like arbitrary code. Yeah, I can understand that position. That said, I really want to call this out. Like I said, this was a known uh technique for the escapes already. I kind of just want to call this out as like, it's here on GitLab. If you're in containers, like, it's worth keeping in mind these known techniques and just pointing out the fact that, it's still there in GitLab. So if you end up in the right situation, this might actually be a benefit to you.
All right, so for our last topic, we have a last minute ad from a report that Z found interesting. So, Z, I'll let you take this one away.
Yeah, this was a Nextcloud. The title here is, in the Nextcloud client, bypass the protection lock in the Android application. This reminded me of a vulnerability I saw in assessment once. It's not exactly the same, but effectively what this bypass is, and I'm not exactly sure what this protection is. All they mentioned here is, add a security password to protect the app. So I'm assuming this like opened the application, it asks you for a password, and then you enter the password and do whatever you want. So in terms of bypassing that, I mean, another common thing is just looking for exposed intents that you can basically activate immediately and get around the password prompt. What they did here, though, was effectively open the Nextcloud app, set the password, whatever, open the app, and then force close it on Android. Reopen it, force close it, and do that between 3 and 4 times, and they'll be able to get, or they'll bypass the lock basically after that. So what I've seen in an application before was that they would detect this this force killing as a crash of the application. So the application was running. It's like, hey, this feature, this thing, like this is crashing the application. So let's disable it. And they kind of had that as a feature to disable security mechanisms. Not a very smart feature, but it was there, and I have seen that. This reminds me of that, but reading the actual discussion with the developers, it sounds like this might have been with very specific devices, not like an intended feature. They mentioned like they managed to reproduce it on a single device. They call out some particular things here, so I'm unclear if that's what they actually did. Or I guess I just see now that they have a patch here. Or pull requests that this might. I didn't take a look at this before the show.
Yeah, so it's kind of interesting that this only worked on certain devices. I wonder if that's just because the force stop, like how the force stop functionality is implemented, is slightly different between different forks of Android. Because I never really thought about it. Like I never really looked into the force stop mechanism. I imagine it's just like sending a signal to the process or something.
Yeah, it
Um,
effectively just kills the process.
yeah, it just sends
Um,
a kill signal.
I will note, so like I said, I didn't look at the commits beforehand. I saw that link and I thought it was just a link. They mentioned it as like if you want to try the build from here. So I just assumed it was a build link and didn't actually look at what it was. Looks like they have a couple commits here that deal with updating the lock's timestamp and using an abstracted clock implementation. So I'm not sure if that's going to be related, but it seems interesting there, and could potentially be something if they were to track like a close time or something. I guess force close probably wouldn't implement with that, but I don't know. The other one here, I don't know. I guess there are a few things that could be related. I'd have to dig through these more to actually know which commits are related or not, but sorry, was just looking at one. Oh, no, it's an interesting bug, like I said, because this doesn't seem like an intentional feature. And like I said, the other time I've seen this was like an intentional feature to just disable it because it seems to be causing problems. And yeah, I mean, force killing applications can create some interesting bugs. Not usually security related. Usually it's more related to not like cleaning up or maybe still holding something in a database when they shouldn't, like remote database. More things like that when you force kill and it doesn't get the chance to properly clean up. But it's an interesting thing to try here when it comes to bypassing those sort of in-app locks. Granted, the ideal way you do these in-app locks is to use some sort of encryption, so you need to provide the key in order to decrypt a file that's then used for, like, maybe authentication with the API, whatever it needs to do, but, like, you need to decrypt the file in order to do it. And that way, even if you bypass the prompt, you're not getting past the actual protective mechanism. I don't know. I thought it was interesting and at least worth calling out here. They got either a $100 or $200 bounty. It looks like they mentioned here on the side of the page it says they were rewarded a $200 bounty, but I also see Nextcloud rewarding with $100. Oh, so that was the bonus. Yeah, $200 bounty. God, if they did it twice. So yeah, $200 bounty for it. I mean, not a huge bounty, but not a crazy issue.
Yeah, and like you said, it is kind of interesting in the way that I've hit a lot of bugs with force stop before because I have an Android TV that I absolutely despise and don't even use anymore. I don't even use the smart functionality of it anymore, but I had to force stop applications quite a bit, and yeah, it creates some really annoying bugs, and most of the time that's all it is annoying bugs. So, it's kind of cool to see sometimes it can yield security bugs like this too. Like you said, though, kind of that defense in depth aspect would have saved them here if they use the password in a more ingrained way than just like a wall. But yeah, I mean, that's how Nextcloud used it, so the attack worked out. All right, Z, unless you have any last minute things you want to add in, I guess we'll go ahead and wrap up the show.
Yeah, no shoutouts.
All right, cool. So that's where we'll wrap it up. Thank you everyone for joining us. Check out our website or chat for Twitter and Discord links. You can also find summaries and VODs for our previous episodes on our website and on our YouTube. Other than that, though, we'll be back tomorrow for our binary topics. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.